Okay, today we have 12.1, the chain rule. So we have learned how to differentiate quite a few different functions. Now today we're going to focus on something that looks something like this. Notice that there's a power 4 there. So what's going to happen here is this: do we need to actually expand this using the binomial theorem so that we can actually differentiate each of the different terms? We don't need to do so because we have a tool, and that's called the chain rule itself. So let me just try to help, okay, to show you how it's done. So now, how the chain rule works would be like this. We want to differentiate y equals to x squared plus 1 to the power of 15. So if I attempt to differentiate y with respect to x, it works in the same way. So first, the power 15, we bring down the power 15 to x squared plus 1. And similar to what we have done, okay, we minus 1 to the power. But be very careful. Notice that when we are doing this, there's still a bracket there. So what we need to do is to differentiate the bracket, and then we multiply it to whatever we've been differentiating so far. What do I mean? If you differentiate x squared plus 1, you will get 2x. So what I'll do here is I'll just multiply by 2x. Can I put it in blue? 2x. So if I simplify, what I get is 30x x squared plus 1 to the power of 14. That's it. Okay, that is the chain rule itself. Okay, please try 6, and I will assist you in 3, 2, 1. Let's go. Okay, I hope you have tried it already. Given that y is there, if I differentiate y with respect to x, we take the power, we bring it down, so I get 10. 2x squared plus 3x, then similar to what we've been doing, 10, we minus 1. Don't forget, the special thing now is that we apply the chain rule. You need to differentiate what is within the brackets as well. So when we do that, what we get, I'll write it in blue, is 4x plus 3. So if you were to simplify, you get 10 times 4x is 40x plus 30. Don't forget to close the bracket. 2x squared plus 3x to the power of 9. Or in what the answer is given, you can actually not multiply the 10 in. I went to multiply the 10 in, that's why I get 40x plus 30. Okay, example 7. Okay, I'll just do example 7. It's still similar. We're applying the chain rule. So y is equals to r cubed plus 1 to the power of 1/3. It is similar, so if I differentiate y with respect to x, first bring down the 1/3, I get r cubed. Oh, I made an error here. Where is my error? Okay, notice that the term inside here is r. Okay, here it's t. So I should not be differentiating y with respect to x because there's no x inside here. What I should be doing is to differentiate y with respect to r, like this. So take note of the notation there. Okay, as I was saying, back to the differentiation. 1/3, it comes down, so it's r cubed plus 1. So it's 1/3 minus 1. Then don't forget to differentiate what was inside the bracket. R cubed plus 1 becomes 3r squared plus 0. So if I have to simplify, 1/3 times 3r squared, I get r squared, r cubed plus 1 to the power of negative 2/3. Okay, now I'll do part B for all of you. So similar, okay, for part B, it works like this. This is h is equals to t squared plus 3t minus 2 to the power of negative 2. So now what will happen here is this: if I were to apply the chain rule, now I'm differentiating h, not y, differentiating h with respect to t, okay, not x. In this case, it is t. So what I have is dh dt over here. So what I'll do is the negative 2 comes down, t squared plus 3t minus 2, then negative 2 minus 1 becomes negative 3, and then I differentiate what's inside the bracket, so I'll get 2t plus 3, like this. So if you want to simplify all of it, what I get is negative 2, 2t, so let's see, 2t plus 3 divided by t squared plus 3t minus 2 to the power of 3. So I just express this part, put it to the denominator to express it in positive index form. Okay, can you take some time now to try 7? And I think that's the last part of this lesson. Okay, if you have done, unpause the video and we can do in 3, 2, 1. Part A. So first I express it into something that I can actually use. So I get 5x minus 1 to the power of negative 3. I differentiate y with respect to x. So I get negative 3. 5x minus 1 to the power of minus 3. Negative 3 minus 1 is negative 4. Differentiating inside the bracket, I get 5. So if I want to tidy it all up, I get negative 15 over 5x minus 1 to the power of 4. For part B, I express it as 7x squared plus 6 to the power of half. I differentiate y with respect to x. So first the half comes down, 7x squared plus 6. Half minus 1 gives me negative half. If I differentiate inside the brackets, what I will get here is 14x. So if you to simplify everything, or make it look a bit neater, so what I'll get here is half times 14x is 7x over the square root of 7x squared plus 6. And I believe this is it for 12.2. Okay, let me just go back to the answers there, and thank you.